Hello everyone, today we'll be talking about red and black tree insertion. Alright, so red and black tree insertion is very similar to BST insertion. The only difference between red and black tree insertion and BST insertion is in red and black tree insertion, you are doing rotations and you're changing colors. That's it. You're doing rotations and changing colors to balance the tree. That's it. So what are the rules in a red and black tree insertion? Alright, if the parent is black, if the parent is black, you just simply insert it. So when you're inserting, the node will always be red. Again, when you're inserting, the node will always be red. So if the parent is black, then you just simply insert the node. Now, if the uncle is black, the uncle is red over here, and this is the new node, you do LLR rotation or RL rotation from AVL trees. All right? So you do the rotations from AVL tree. And then if you see a tree like this, if it's not straight, it's like this, it's a bit of a curve, you do RL or LR rotation. You can see the uncle is black and we just rotate it. Similar to AVL tree. LLR, you just take the concept. So you can say, in a way, you do kind of an AVL tree rotation if the uncle is black. All right? And I know there's zigzag and zag-zig, but we're just going to call them LLR, RL. We're just going to borrow from AVL rotation to keep it simple. All right, now we go here. Now, if the uncle is red, you just change the colors of the uncle and the parent and the grandparent. That's it. All right? Just follow these simple 3 rules in red and black tree insertion and you'll do okay. All right. Right now we're going to do the insertion. Over here you can see this is the screenshot I got from Abdul Bari's Udemy course on data structures. I took a screenshot just to keep everything simple and we could use this as a reference. All right. So the first, let's do this. The first element we're going to insert is 10. So when you insert, it's always going to be red. 10. Now, what's the rule in a red and black tree? The root node cannot be red. So we're going to change the color to black. So now we change this here to black. And this one here is supposed to be 60. Let me just make the black. All right, I'm just going to do this one again. This one here. This one, sorry. Let's make this one here black. Here, when we do the insertion, it's red. And then we change the color to black because the root node has to be black. All right. Now we inserted 10. All right. Right now we're going to insert 20. All right. 20 is inserted. All right, 20 is red when we insert it. We do not have to do any rotation because, again, the parent is black, and so if the parent is black, we do not have to do any rotations or change any colors. Remember that. I'm just gonna, maybe we should make a note here. If parent is black, don't do anything. All right. Now we're going to insert 30. Let's make 30 much better. Here. And 30 is red. All right. And what do we do now? As you can see, we have our uncle here, our grandparent, our parent, and our new node. So we do a rotation. So in this case, we do LR rotation, or you could say zig rotation. So we're going to rotate so 20 so again we do say this is RR rotation. Sorry, this is, I would say this is LL rotation because we're doing left LL rotation. And then here, and I'm following this case over here, zig. And here is 30 red and 10. Now we change the colors. So when we do a color change, so right here, okay, and I'll just do it over here. Here, you could say this one here. Oopsie. $20 is black. 10 is red, and 30 is red. Oh, oops. And then make 30 red. Okay. Now we could erase this here. Oops. And just be careful when you erase. Okay, awesome. We'll move this here. All right. So we inserted 30. All right, now we're going, so let's check 30 off here. And we're going to insert 50. And 50 is red. All right. And all right. So we could say what. So we go here. We're just going to break it down. G, uncle, parent, new node. The uncle's red. So what we do is we change the color. So we're just going to go here. We're just going to change the color. We're going to follow this case over here. Uncle's red, so we just change the color. $20. Red. Okay. These here are black. All right, and we can't, sorry, this one, but make it this one red, sorry. And problem here is we cannot have a red node. So we just then make 20 black. So okay, just gonna erase this. And we make 20 black. All right. Remember that after you do the coloring of the node, the root, if the root node is red, we turn it black. That's another rule. If the root node is red, we turn it black. We make it black. After we follow the case. So let me erase this now. We'll bring this up here. Okay, we inserted 50. Now we're going to do 40. Okay, so we go here. We insert 40 here. All right. We look at the case, uncle, grandparent, new node. And what case should we follow? We should follow zigzag rotation. So I'm just going to do it here. So we put 40 here. Okay. And then 30 and 50 become red. 30, and then you could say here it's 50. Okay. Now we move this one up. And we have inserted 40. All right, now we're going to insert 60. So do 60 here, 60. Okay. So right here, see, look, Uncle G, parent new node. We just changed the color. So let's see if I quickly just do this. I can change 40. Make 30 and 50 black. Try to get over the lines here. Okay. This is a 5. Actually, just let's do a quick erase. Here, here. Here. Change the color. You know what? I'm just going to erase them. Save some, make it more clearer. Okay. Oops. $30, $50. Yeah, it would have been faster if I just erased them. All right. So 60 is inserted. All right. Now we're going to insert 70. So what we're going to do here, put 70 here. $70. And let's go break it down again. So you have here grandparent, parent, node, and uncle. Uncle's black, so we do a rotation. Just going to see if I can move this up. Oops. No, I just want to move this. Okay. Okay, let's just try to do the rotation here. Okay. So we do LL rotation. So we're going to follow zig. So 60 would be black. And $60 here, and 50 and 70, and then these will be red. And then we're going to put this new rotation over here. We're going to erase this and add a rotation. Okay. We have inserted 70. Let's check that off. Now 80. Okay. And the uncle, you could say the uncle is red, so we're going to just do coloring. So 60 will become 60 will become red. $50 and $70 will become black. Oops. Okay, we have a conflict here. 40 and 60, two consecutive reds. So we're going to recursive in the code. We would recursively solve this. So now what we would do here is we would have to rotate this. So now you're looking at this. Now we have to go here and now recursively Went up the code. We have a conflict here, so you could say 60 is a new inserted node. This is the parent, grandparent, and 10 is the uncle. Okay, make this G. That doesn't look like a G, but okay, good. So we're gonna rotate this. So, and we're gonna do the rotation here. We wrote bus. Okay, we're going to do the rotation here. 40. Okay, and we're going to do a zig-zag rotation from over here. 40. $20 will go here. And oh, 20 will be red. 20. Okay. And then we'll have 60 here. 60 will also be red. So now, okay, I'm going to keep this for reference here. These ones here, we're just going to keep them here. Now, what I'm going to do is I'm going to bring 40 and 60 here, red. And then this is like avial rotation, so here, this one, 30, 60, will now point to 50 and 70. And that's how we do our rotation. All right. And we could delete this over here. Okay. We have inserted 80. Now we're going to insert 4. And 4 will be an easy insert, since it's going to go here. And we know that 4's parent is black, so we do not have to take any action. We don't have to change colors or do any rotation. And that is it, guys, boys and girls. So we have, to summarize everything, we have 40, 20, 60, 10, 30, 50, 70, 4, 80. And this is how you do insertion in a red and black tree. And just follow these three. Follow case 1, case 2, case 3, and you'll be fine. All right. Thank you for watching.